Very impressive pictures. Before we continue with Guy, who is not using a constellation, there's a question to the constellation users, Hyun and Ivan, from the SMS. After experiencing an eye collapse and retinotomy incarceration with an IOP control system with a constellation, I stopped using it. Have you experienced a similar complication? Hyun?
Okay.
How did that happen?
Okay, that happens sometimes because in case of IOP surgery, just after the IOP surgery, the vitreous is sometimes peeking into the infusion line. And then if you do a vitrectomy again, the infusion pressure detector think that the pressure is enough inside the eye. So you have to remove the vitreous from the trocar. So I recommend you to vitrectomy start with around the infusion site at first time, and then if the cases happens, you have to increase the intraocular pressure.
Ivan, was that person's reaction the correct one to stop using the constellation, or what would you have done?
Well, it's another question. Collapse of the globe should not happen, but I think
retinotomy incarceration was basically the problem. First a collapse, and then the retinotomy, but yes, the retinotomy incarcerated.
I think it's two questions. Collapse is one, and incarceration is two. Collapse of the globe should not happen because of the IOP control. As I said, I had the last collapse of the globe when I was trying the peristaltic pump for 1 day only. But of course, I can do collapse of the globe performing air fluid exchange and just jumping on the foot switch down to the bottom. I can make the collapse of the globe intentionally, but it doesn't happen unintentionally when I know how to use the foot switch. And concerning the retina incarceration, you mean like in cases when we perform, for instance, peripheral retinectomy or retinotomy, then it gets incarcerated in the cutter. We have the backflash switch, and we simply jump on the bottom, and it has linear backflash. It makes woo, and the water goes back from the vitrectomy together with the retina, so we can easily release the incarcerated retina if it was the subject of the question.
I'm not sure whether they meant the incarceration in the cutter or incarceration in the trocar. Not quite sure about that. Anyway, let's continue with Guy.
Yeah.
He uses a Stellaris.
Yeah. Put on the next, the videos on the screen.
Oh, now we have Keith. Sorry, Guy. We don't like you.
Okay. Good afternoon, everyone, and thank Didier and Klaus both for the opportunity to be here today. Really what I'm going to talk about is flow control in my experience. There certainly has been much lively discussion, and particularly most recently yesterday, regarding the effectiveness of vitrectomy using a vacuum-based system versus a peristaltic or flow-based system. For the last 25 years, just like Michael Schumacher has dominated Formula One racing, vacuum-based systems has dominated the vitrectomy world, in particular in the United States, but also worldwide. However, there has been some recent changes that has really made peripheral vitrectomy in particular, and small sutureless incisions, has really made attention to fluidics much more important today. And so our current vacuum-based systems have really developed methods to address flow, that is, changes in duty cycle and the use of high-speed cutters to address fluidic issues. Flow control-based vitrectomy really allows for control of these fluidics without having to change or make alterations in the duty cycle and or the cut rate. And the preliminary work, particularly that work done by the EVRS looking at vitrectomy, has really suggested that there is a lower complication rate and a higher success rate when one is using a flow control-based vitrectomy system. So the EVA, which has been in Europe for some time, was launched in the United States back in last year, March of 2015. And it's very good because it contains both platforms, that is a vacuum and or a flow-based system, in addition to having phacoemulsification capabilities. And this is just an example of doing peripheral vitrectomy here using the flow-based system, you can see the retina is pretty stiff, not moving very much, even though we're cutting the vitreous out very, very nicely here. So what I did was I looked at the first 53 patients this year that I used doing both a vacuum-based and a flow-based system using a 23-gauge port size or gauge size for vitrectomy in these patients. Patients in the vacuum cutting group had surgery performed with the cutter at high speed and for all segments of the surgery because, again, it was the best way to control the flow in those patients. Patients in the flow group had surgery. However, we were able to vary the cutter speed in those eyes, ranging from 100 cuts per minute as low to as high as, of course, to 16,000 cuts per minute using the TDC cutter. And that really depended on what the clinical setting was. If there was a clinically significant cataract present, and I'm saying this again, if there was a clinically significant cataract present, I, that is Keith Warren, a retinal surgeon in the United States, did both procedures, both vitrectomy and phacoemulsification in the same surgical setting. And both platforms we used to evaluate its effectiveness in surgical time, complication, and ease of membrane dissection. If we look at the demographics of the two groups, and this is going to be published in Ocular Surgery and Lasers later, they're really fairly similar. 25 eyes in the vacuum-based group had very similar pathology as the eyes did in the flow-based group, the only exception being we did a dislocated intraocular lens in the flow-based vitrectomy group. So both groups were really fairly similar in their demographics. If we look at surgical times, and I want to be clear that the surgical time refers only to, not the case, but only time that it took to remove the vitreous. So we timed how much time it took us to remove the vitreous. Really, we found that it was fairly similar, 23 minutes in the vacuum-based group, about 20 minutes in the flow-based group. And as you can see, for most of them, the vitrectomy time itself was fairly short, except in cases where there was the need for peripheral dissection and or membrane dissection. Obviously, those cases took a longer time to do because of the complexity of the case and surgery involved in those cases. We looked at complications, which is really the most important thing. They were really fairly equal, excepting the occurrence of retinal breaks. This certainly mirrored what was found in the EBRS study. That is, there were 30 breaks in the vacuum-based vitrectomy group eyes compared to only 18 retinal breaks that occurred in the eyes that underwent flow control vitrectomy. The most frequent complication, again, was retinal breaks in most groups, in both groups rather, and this only occurred in patients who were undergoing the peripheral vitrectomy and or membrane dissection, that is, removal of fibrovascular tissue and peripheral PVR. The most frequent in vacuum-based was obviously the retinal breaks. And in my hands, I actually found a slightly higher break when I use a TDC cutter, probably because the cutter opening is open the majority of the time and more likely to cause a break under those circumstances. If we look at membrane dissection, this is required for the treatment of retinal detachment and PVR. And as was stated earlier, when you use flow control, this is truly a Swiss Army knife. It is very versatile. You can go to very slow rates when you need to engage the membranous material to very high rates when you're cutting the central vitreous. So it really allows one to adequately shave under flow-controlled conditions. And and obviously there were lower breaks that occurred. And finally, certainly there was a case where phacoemulsification was required in some of these cases, and it was really very efficient. The handpiece was very friendly and easy to use, and actually some of the surgeons, the cataract surgeons in our facility, liked the unit, liked the capability of the phacoemulsification, and so it was really very instrumental in us being able to purchase a unit for our ambulatory surgery center. So in summary, EVA provides an efficient method for surgical treatment of a variety of complex retinal disorders. I liked most about it, honestly, that it was very versatile, that I could do combined surgery, that is phaco and vitrectomy, using a single unit. Retinal breaks were more common using the vacuum-based system, and that is no different than what we previously knew from the EBRS study. And finally, versatility was really a very important decision in our ability to purchase this because our anterior segment surgeons also liked the phacoemulsification capability of the EVA unit. And I got a greater sense subjectively of safety using it for membrane dissection and peripheral vitrectomy. Thank you very much for the opportunity to talk to you all today.
Thanks, Keith. Didi, it's your turn.
Yes, I would like to present you a movie that I presented yesterday that I could not present at the American Academy subspecialty day, but fortunately we are an open mind society where the surgeon can present what he wants, even if this does not please the industry. There is sound.
Hopefully.
Yeah, it's okay.
The IVRS-RD study, analyzed by the French National Institute of Statistics, demonstrated that vitrectomy performed with the Venturi pump machine almost triples the failure rate compared to the use of a flow control pump, independently of the surgeon's experience, age, and nationality. Let's try to explain why. Since a Venturi pump does not allow to control the quantity of liquid entering the handpiece, a low cutting speed cannot be used, otherwise the risk of bruising the retina is too high, as illustrated in this case, where 600 cuts per minute had been selected. To decrease the dangerousness of the handpiece, a high-speed cutting is mandatory, but this is at the expense of a limitation of both performance and effectiveness. For example, it has been established that removing the posterior haloid is statistically linked to a lower failure rate, I want to do so in this case where the vitreous cortex is adherent to the retina. The cutting rate has been set up at 4,000 cuts per minute, and look, the retina does not move because the adherent vitreous does not come. And this can be illustrated. A curved needle passing very close to the retina can catch all the adherent vitreous that has not been removed during the high-speed cutting. To remove the haloid, one has to achieve a peeling maneuver. The vitreous is a non-Newtonian fluid. It is the BSS that carries on the vitreous fibers into the cutter's port. With high-speed cutting, the vitreous cortex itself does not have the time to enter in between two cuts, and a shaving maneuver is performed, allowing PVR to develop post-operatively, while the cortex peeling dissection does prevent it. At the periphery, a peeling cannot be performed, but the issue is just the same. If time is not given for the vitreous to be attracted into the port, then a thick mattress of collagen will remain at the vitreous base as illustrated here. I start at 8,000 cuts per minute and 14 cc's of aspiration flow. The level of required vacuum indicates that only the BSS around the port is aspirated. The vitreous will only be attracted and cut when the cutting speed is reduced below 2,000 cuts per minute. As the vitreous does not come, one can think to enter into the vitreous base, but one ends up with a row, and withdrawing the cutter's tip will only achieve such a poor job. To achieve a more complete job, time must be allowed to the adherent vitreous to move toward the port, but then the retina will follow. To avoid catching the retina, one must use a low and precise aspiration flow between 1 to 3 cc's per minute, lower than the natural outflow of BSS induced by the infusion pressure. To obtain such a low flow, the flow control pump acts like a dam that reduces the flow of a river while creating a positive upstream pressure. In this case, where the vitreous surrounding a retinal tear is dissected cut by cut, one can see that pressure measured at pump level is positive, while aspiration flow is very low. Such a precise dissection cannot be achieved by a Venturi pump, which performance is limited to generating a negative pressure, increasing the gradient of pressure, and therefore the natural outflow of the BSS. aspiration flow control pumps allow a safer posterior peeling and a more complete peripheral shaving, explaining why the failure rate is lower. Phacoemulsification techniques have been mastered in order to improve extracapsular lens extraction. Flow control vitrectomy should be mastered as well for the efficiency and safety of vitrectomy.
This is to say that even if in the future we have a new venturi pump equipped with a flow sensor in the aspirating tubing, commanding the venturi pump, so doing a kind of aspiration flow pump, this will not act because you cannot have a positive pressure with the venturi pump. You are obliged to work with a negative pressure and then to have a minimum aspiration flow which can be too high. So this is why venturi pump, whatever they can find to increase the security, will not be as safe as the peristaltic pump. Thank you.
Actually, this is the wrong screen, but can you do it this way? Okay. No, it's okay. Don't worry. We're good. So, Guy? No, you have to tell me to change the slides.
The first, please.
Always look on the one on the left.
The first one.
First one,
Just
okay.
before, yeah.
Like so.
This one, okay.
Okay. You're on. You're not going
You can
to
put on the full screen?
Huh?
You can put the slide on the full screen?
Yeah. I would have to go back to the settings.
Nice boat.
Huh? Are you happier now?
Thank you, excellent.
Okay, go ahead.
Thank you, Klaus. As I told you, every week I have to switch between two different OR for the surgery, between my private practice with Eva and the Steris PC in the hospital. And there is some small differences between the two machines, but the quality of my surgery is quite the same in the two different OR. And the Steris you see on the screen is an evolution of the Millennium. And the Millennium had two pumps, flow control pump, like Claude showed on the video, and the second venturi pump. The same pump, the same concept of pump you have on the Steris, but the interface is totally different, more sophisticated on the Steris PC. Next one. One of the key of the setting of the Steris PC is to optimize the double linear foot pedal. And the part of surgeon using that type of foot pedal in double linear function is very low, less than 2% of the person using a Steris PC. And this pedal gives you two double linear function. You can check the vacuum and on the other side, the cutter frequency. And that gives you the possibility to adapt and to control the two parameters of the surgery during the different part of the vitreous you have to cut during the vitrectomy. And this function can be set in a free zone setting on the page of the setting of the vitrectomy to obtain a different sensation during the vitrectomy. And the control of the vitrectomy became a three-dimension control if you change the position of your foot on the foot pedal. The next one, please. Yes. You can see on the screen the different parameters you have to check to secure the vitrectomy. And all you can see on the screen is the three different areas of the setting of the pump, and the way you can move the foot pedal, change the position between the three different curves on the screen. And this allows you to adapt the position of your foot to change the parameters during the vitrectomy. If you are very close to the retina, you can reduce the vacuum and increase, if you need, the frequency. And if you have in the center of the vitreous, you can increase the vacuum because it is very secure to manage the vitrectomy in the center of the vitreous. And when the vitreous change its viscosity, you can change all the parameters to adapt the vitrectomy and to secure it. The next. The first parameter you had to check in the setting of the pump, this time not of the foot pedal, the setting of the pump, is the maximum vacuum you have to use, you want to use during your vitrectomy, when the pedal is totally down. The second is the delay. As I told you yesterday, the delay is the time the pump gives you to identify what happened at the tip of the cutter. The delay can be at 2 or 3 seconds if you want to train. It was the case yesterday in the video for the fellows. But when the delay is at 1 second, the pump becomes very reactive, and the time you have to identify what happened is very short, could be less than 1 second. That's probably what happened in the video showed by Didier, was the incarceration of the retina inside the probe. Because if you increase this time, you can stop the cutter before the retina comes into the cutter. If you have choose the nice curve for the pedal, you can find the right position to be very secure in any place inside the eye and to control all the time what happened and during the vitrectomy at the base and very close to the base because I use it for endoscopic vitrectomy. The next one. Here are the different parameters I use in my routine practice. As you can see, the delay is very short. It's less than 1 second because I need a very reactive machine. For the fellows, the delay is at 3 seconds. The curve of profile is not a linear profile because with that type of profile, you have a very nice control for the very low flow when I reduce the vacuum. And that secures the aspiration when you want to touch the retina, as you have seen on the video. The control of the vacuum is completely secure if you restart the foot pedal. Because if you want to have the delay to identify what happened, you must stop the vacuum and restart it to have the delay to secure what happened. It's a little bit more complicated, but it's just a question of training. You can put the next. This is a video of an ophthalmitis with a 20 gauge vitrectomy. And as you can see, we are very, very close to the ciliary body, a very dangerous place. And the traction are completely controlled every time we are very close to the ciliary body. And because the vitreous is quite wide, it is very easy to identify what happened at the tip of the vitrectomy. And we are very close, less than 1 millimeter, and everything is under control. So if you check the pump and the foot pedal the right way, it is possible to work very secure and so close to the retina with the venturi pump. The next one. The next one is a giant tear with PVR. And here too, it is a 23 gauge vitrectomy this time. And here, this is a shielding free, a very small, it's not a iatrogenic brakes. It was in place before we start the vitrectomy. As you can see, it's possible to cut the retina and enlarge the tear and to obtain a very nice shading. And everything is completely different than what you have seen on the accident with venturi pump, because here everything is totally secure if you take time to check the setting the right way. Thank you.
Thank you. We have a question from the SMS. Didier, what cut rate did you use or do you recommend for retinal detachment, and was the cut rate considered in the EVR's detachment trial?
So the cut rate must be adapted to the flow. When you begin your vitrectomy, when you perform the central vitrectomy, you want to be efficient, so you have a flow around, let's say, 6-8 cc's. And at that moment, to avoid any traction on the periphery, you have to cut at least at 610 hertz, 600 cuts a minute, or 800 cuts a minute, because you don't want to exert traction at the vitreous base. When the central vitrectomy is made and you approach the retina, you are in BSS. So you must know that this is the BSS that attract the fibers, the vitreous fibers, to enter in the port, as this is the flow of the river that transport a tree. So when you approach the retina, this is the fibers of vitreous, this is the retina. So you open the port, the fibers is elastic, it does that, and at that moment you must reduce the flow to cut when you want, where you want exactly. If you cut fastly, the retina will do that only. The vitreous fiber will do that only. The retina will not move. The vitreous fiber will do that, and you will not attract the vitreous fibers. This is why if you use a venturi pump, you should, and this was proved by the RD study, you should use a high-speed cutting. Because if you use a low-speed cutting, each time you catch the retina. So what I do is when I want to remove all the vitreous close to the retina, I lower the cutting rate. But of course, at that moment, I work between 1 to 2 cc's per minute. So I can control exactly what I'm doing and where I want to cut the vitreous.
Guy, it was quite impressive seeing you work so close to the retina and suck the subretinal fluid out. It was almost like the endoscopy that Claude showed, except when you were cutting, there was much less control. Do you agree with that?
In my practice, being so close to the retina in endoscopy can be controlled with a venturi pump. The problem is how you check the pump.
Yeah.
You must have a very, very low flow when you just start the vacuum. And that's possible if you have a curve like you have seen on the screen. That give you time to know what, and to identify what happened. But sometimes you have to stop the vacuum and restart it. It's just a small movement of the foot on the foot pedal. Just release the pedal and restart the pedal just to have this delay to protect you.
Are there questions from the audience? Come up, please. But what you're effectively saying is that in that Stellaris machine, you really got to understand all the parameters very well, and which is contrary to what I always believed, that the American machines were made simple.
No, it's not a simple machine. No, sure. It can be if you use it with a very high speed, like the Celit, because the Celit with a program like Alcon is a very shaving program with a very high speed cutter.
But we haven't reached the stage yet where the machine knows what the vitreous is like.
Could be that.
Yes, I have a question in my mind. I think there's a fight between venturi and peristaltic pumps. I want to tell you a story about this. when I was a fellow with Dr. Payman in 1987, I was invited to Alcon. I'm mentioning that I have no financial interest. They have a huge R&D department. It's a very big company. And I'm doing vitrectomy for the last 27 years. I'm only using Alcon machines. First Acurus, before Constellation right now. My question is this. I'm attending the EBR's meetings from the first beginning. And always there's a fight between peristaltic pumps and venturi pumps. And Alcon knows about this. And they are a huge company, and they put a lot of money on research, R&D development. Why aren't they trying to convert their machines to peristaltic pumps? Because they know about this, and they have a huge R&D department, and they can do it. Why aren't they doing it? My question is this.
You want my answer?
I want everybody's answer.
Until recently,
it's a huge company. They can do it.
Until recently, they believed they had a monopoly. Now EVA is there.
I'm sorry?
Until recently, they believed they had a monopoly. Now EVA has entered the American market, and I think it's going to change.
But if it's good for the patient, why don't they convert their pump to peristaltic pump?
Yeah, but Murat, we had that fight yesterday. We actually decided not to have that fight today.
Okay.
Is there any answers on your side? Continue with Steve.
No, Alcon was ruled by Steve Charles. They were overwhelmingly ruled by Steve Charles, who thought that he could change the duty cycle.
Because it was Bausch before.
I'm sorry?
He was Bausch long before.
Yeah. And so he thought that he could change the duty cycle and do the same thing. Mm-hmm. But I think he's wrong, but you know, Steve and I have all argued and argued and argued. He's not here, unfortunately. Now, but you never said, Didier, what the cutting rate was when you're trying to shave with that low 1 to 2 cc flow rates.
It could be between 1 hertz and, this is to say, 1 hertz is one cut per second, or half a cut per second, or cut by cut when you want.
Really?
Up to 60, 200 cuts, 500 cuts a minute.
So that you're really saying when you really want to get down to that gel that is right adjacent to the retina, you really do it so you can cut like the super chef who cuts exactly the gel that he wants.
Yes.
Not any kind of shaving. So we should stop using the word shaving because we're really doing something very different.
Unless you actually shave, which most people do. But it brings me to one last point, and that was the foot pedal. I mean, Didier and I, and these machines, we have this dual linear control, which means that we control the flow in our cases, Stellaris per se the vacuum, and we control the cut rate like that, which is a logical thing to do. I mean, I control the flow, I control the cut rate, I hear the vacuum, so I control everything. Now, Alcon machines only have this movement, and they call it 3D. Can you explain that to me? I've never understood it. Ivan, what is 3D foot pedal?
3D is just an acronym. It's a dual dynamic device or something like that. So it has nothing to do with 3D. It means that you move your foot in 3 dimensions. It's just a stupid
So
market.
how do you control your cut rate?
I control the cut rate in the opposite way than the vacuum.
Oh, so they are linked?
Yes, in the opposite way.
Okay.
They are crossed.
So the larger the vacuum, the higher the cut rate? Or the other way around?
No, the other way.
The other way. Okay. Any other comments? Nothing from the audience? And we're out of time?